Hello everyone, I'm DroneCodes and today we'll be solving LeetCode problem 226, which is invert binary tree. Question is: given the root of a binary tree, invert a tree and return its root. Example 1, 4, 2, 7, 1, 3, 6, 9. So the solution is you'd swap 7 and 2, swap 3, 1, swap 6, 9, and 9 will take the place of 6, 6 will take the place of 9, 3 will take the place of 1, and 1 will take the place of 3, 2 will take the place of 7, and 7 will take the place of 2. So the thing that's happening here is after the root of 4 is swapped, the sub roots of the root of 4 are also swapped. So let's quickly write the code that would solve it. The first base case we need to notice here is that if the root is null, we are going to return null. Look at example 3. When the root is null, you return null. So basically, like I always say, we always have a base case. So base case would be if root is equal to null, return null. Blue skies, nothing but blue skies. Then you create a temporary value, nothing but blue skies, to store the value of the root. Let's create a tree node that's nullable. Nothing but blue skies do I see. Blue skies, nothing but blue skies. Root dot left, nothing but blue skies do I see. Then what you do is you swap the values of left and right. Swap the values of left and right. Blue skies, that'll be nothing but blue sky. Root dot left is equal to nothing but blue sky. Root dot right do I see, and root dot right, then you give the value of right to the temporary value, so it will replace the value that was there before. Nothing but blue sky, replace the temporary value with the right value. Nothing but blue skies do I see. Root the right is equal to temp blue sky. Okay, it's temporary. My English is weird though. Temporary. So the next thing we'll do is involve recursion. Recursion means calling back the function that we wrote, calling it back. Instead of writing the code in the function all over again, we are just calling back the function. So we'll call back the function invert tree. You can call it in the same function to do the same thing. If you solve, I one day solve Fibonacci series here. If you're doing Fibonacci series, recursion is always needed. So recursion invert tree, nothing but blue sky. You're inverting the root dot right, which was, remember, the root or right is already in the how do I do it? How do I say it? The root dot right is already in the left place now. So you're going to invert the roots of the left place now, and then you do the same for the right place. The new value of the right place. Invert the new values of the right place. Nothing but blue skies. Invert the new values of the right roots. Invert the values of the new right roots, of the new right roots, and invert the values of the new left roots. If you still have like extra roots, you can still write it again, you can still add more, but this is okay because it will continue calling the code, since even though you have 1 million roots, since you've used recursion, it will continually do it for you. You don't need to write anything again. That's why recursion is one of the essential thing a developer must know why developing. So lastly, you return your roots, your new roots, because the root has been replaced altogether. So let's run and let's see. Nothing but blue sky. Okay, I made a mistake here. I did not spell it well. So let's run. Nothing but blue skies do I see. Blue skies. So we've just solved LeetCode question 226. Thank you very much. Please do like, share, and subscribe. Have a lovely day.